Welcome to Paper Trail, where we make academic research accessible and engaging. Let's see what the evidence says. For years, images out of China depicted cities choked by an almost impenetrable smog. The air quality was notoriously bad, posing a severe health risk to millions. So, when the government declared a war on pollution and succeeded in dramatically clearing the skies, it seemed like an unequivocal triumph.
It certainly did. The policy successfully reduced fine particulate matter, or PM 2.5, by nearly 40% in eastern China. That's a staggering achievement, saving countless lives and making the air visibly breathable again. But this new NBER working paper, titled The Unseen Costs of Blue Skies, reveals a profound and, frankly, disturbing twist.
An unseen cost? What did the researchers uncover?
While the PM 2.5 plummeted and the skies turned blue, ground-level ozone, a different and equally dangerous pollutant, surged dramatically. The paper's most striking finding is that these hidden costs, the increased human mortality from ozone and significant biodiversity loss, erased approximately 23.8% of the policy's overall net benefits. It was a partial victory, with a much higher price tag than anyone realized.
That's a significant haircut to what was celebrated as a major environmental success. To begin with that initial context, many listeners will recall those alarming images of China's airpocalypse in the early 2010s. What exactly was the scale of the problem the government was trying to address?
The situation was dire. Cities like Beijing regularly saw PM 2.5 levels that were multiples, sometimes 10 to 20 times, higher than the World Health Organization's safe limits. PM 2.5, which is particulate matter smaller than 2.5 micrometers, is particularly dangerous because its size allows it to bypass the body's defenses, entering the bloodstream and contributing to severe cardiovascular and respiratory diseases. Public outcry was immense, and rightly so.
So, the government's response was this ambitious air pollution prevention and control action plan. How did they achieve such rapid reductions in PM 2.5?
The plan was comprehensive and aggressive. It involved shuttering or retrofitting coal-fired power plants, taking heavily polluting vehicles off the roads, and imposing stringent controls on industrial emissions. The focus was laser-sharp on PM 2.5, and by its primary metric, it worked. The thick, gray smog began to lift, and people saw blue skies again. From a public health perspective related to PM 2.5, it saved millions of lives. If the story ended there, it would indeed be one of the greatest environmental success stories of our time.
But as you mentioned, the story doesn't end there. As the visible smog cleared, this invisible crisis emerged, a dramatic surge in ground-level ozone. Many might associate ozone with the protective layer in the stratosphere. Can you clarify the difference?
That's a crucial distinction. The good ozone is indeed in the stratosphere, high above us, where it absorbs harmful ultraviolet radiation. But bad ozone is at ground level. It's a highly reactive gas, a key component of smog, and it's formed when other pollutants react in the presence of sunlight. When inhaled, ground-level ozone causes severe respiratory damage in humans and can devastate plant and animal life.
So, while people were breathing easier from the reduction in PM 2.5, they were unknowingly being exposed to higher levels of this different, dangerous pollutant. The central anomaly this NBER paper identifies is this exact pollutant substitution effect. Why did fixing one atmospheric problem immediately inflate another? Was it just an unavoidable chemical trade-off or something more?
That's precisely the investigative hook for the researchers. Was it a natural phenomenon, perhaps a shift in weather patterns that favored ozone formation? Or was it something deeper, inherent in the policy design itself? To answer that, the authors needed a very robust way to prove causality, which brings us to their methodology.
Causality is always the challenge in these kinds of studies. It's easy to see two trends moving in opposite directions and assume a connection. How did the researchers isolate the policy's specific impact on ozone levels?
This is where the paper truly shines from a methodological standpoint. The authors exploited the staggered rollout of China's national air monitoring network. Think of it like this.
China didn't just flip a switch and have PM 2.5 monitors everywhere simultaneously. The infrastructure was installed in phases across different cities over several years.
So some cities got their monitors and presumably stricter enforcement based on those metrics earlier than others.
Exactly. City A might have received its monitors and become subject to binding PM 2.5 targets in, say, year 1. But City B might not have gotten its monitors until year 2 or even year 3. This staggered timing created a quasi-experimental design.
And how did they use this variation to prove a causal link?
They applied a difference in differences economic model. In essence, they compared the pollution changes in cities that just got monitored, meaning the bureaucratic pressure to reduce PM 2.5 had just gone live, against cities that had not yet been monitored, serving as a control group, all while carefully controlling for other factors like time and location.
That's clever. It allows them to isolate the specific impact of the policy being enforced through monitoring rather than just general national trends or broader economic shifts.
Precisely. The data shows that this pollutant substitution effect, PM 2.5 dropping and ozone spiking, perfectly tracks the localized installation of these monitors. The moment a local mayor knew a PM 2.5 monitor was active and reporting to the central government, the local atmosphere changed. This wasn't a generalized weather pattern or a broad economic trend. It was a direct, causal consequence of localized policy enforcement. It's a powerful demonstration of how the precise design of regulatory mechanisms can have profound and sometimes unexpected environmental impacts.
So this isn't just about atmospheric chemistry, it's about bureaucratic behavior and incentives. The paper suggests local officials were essentially gaming the system.
That's the crux of it. The core economic theory at play here is Goodhart's law. When a measure becomes a target, it ceases to be a good measure. Local officials in China faced strict career-defining targets for PM 2.5 reduction. Failure to meet these targets could mean losing their jobs or missing out on promotions. Crucially, they were not evaluated on ground-level ozone.
So they optimized for the metric they were being judged on. But how does that translate into an ozone surge beyond just neglecting it? Is there an atmospheric process at work here?
There absolutely is. This is where atmospheric chemistry meets behavioral economics. Ground-level ozone isn't emitted directly. It's formed in the atmosphere when two primary precursors, volatile organic compounds, or VOCs, and NOxes, react in the presence of sunlight. Now, here's the critical part. Particulate matter, PM 2.5, actually acts like a chemical sponge in the atmosphere.
A sponge for ozone?
Yes, PM 2.5 particles absorb the chemical radicals that are essential for ozone formation. So when you have a massive amount of PM 2.5 in the air, ozone production is naturally stunted. Atmospheric scientists call this the aerosol-inhibited regime.
So if PM2.5 acts like a sponge, soaking up those ozone-forming radicals, then removing the sponge would be like taking the sponge away.
Exactly. When local officials were tasked with reducing PM 2.5, they had a choice: target all emissions or strategically target only the emissions that gave them the biggest bang for their buck in terms of PM 2.5 reduction. They aggressively targeted particulate precursors like sulfur dioxide and primary dust. But they completely neglected ozone precursors like VOCs and NOx. Why? Because controlling VOCs is typically more expensive, complex, and wasn't required by their performance reviews.
So the atmosphere suddenly had less of its natural sponge, PM 2.5, but the ingredients for ozone formation, the VOCs and NOx, were still abundant, reacting freely in the sunlight.
Precisely. The result was a dramatic and policy-induced surge in ground-level ozone. The paper explicitly proves this wasn't just a benign or unavoidable trade-off. It was a direct consequence of incomplete performance metrics distorting bureaucratic incentives. Officials optimized for the test, and the atmosphere, and ultimately public health, paid the price.
This highlights the deep interconnectedness of atmospheric processes and human decision-making. But the paper doesn't stop at human mortality. It also takes a leap into ecology, looking at biodiversity loss. What did they find there?
This is one of the most compelling aspects of the research. Most economic papers on pollution focus on human health outcomes. This study goes further, measuring the collateral damage of this bureaucratic game on biodiversity, using bird abundance as a key proxy for ecological health.
Birds as a canary in the coal mine, literally.
An apt analogy. Birds are incredibly sensitive to air quality. Their respiratory systems are remarkably efficient. Unlike human lungs that mix fresh and stale air, birds have a unidirectional airflow system, allowing them to extract oxygen continuously. While this makes them incredible flyers, it also makes them hyper-vulnerable to airborne toxins.
So when ground-level ozone spikes, how does that specifically impact bird populations?
It causes severe oxidative stress, damaging their delicate respiratory tracts. Furthermore, ozone degrades the local plant and insect life they rely on for food and habitat. The researchers documented that this policy-induced ozone surge actively reduced biodiversity, leading to measurable, statistically significant drops in local bird populations.
That's a powerful narrative. A decision made in a municipal office focused on hitting a narrow KPI to put a scrubber on a coal plant for PM 2.5 but ignore VOCs ends up hollowing out the local avian ecosystem a few months later. It truly lays bare the interconnectedness of regulatory incentives and natural ecosystems.
It certainly does. It's a stark reminder that environmental systems are complex, and single-metric policies, even well-intentioned ones, can have cascades of unintended consequences.
So this brings us back to the 23.8% reduction in net benefits you mentioned at the top. The paper isn't saying China's war on pollution was a failure. Reducing PM 2.5 clearly saved countless lives, but it's about a rigorous reevaluation of the net success.
Exactly. The authors quantify the unseen costs of this policy-induced ozone surge. They calculate the increased human mortality specifically attributed to these new ozone levels, along with the economic value of the lost biodiversity. And their conservative estimate is that these hidden costs reduced the overall net benefits of the blue sky policy by nearly a quarter.
A massive haircut, as you put it, to a policy victory. If a government claims a policy generated, say, $100 billion in social value, this paper demonstrates that almost $24 billion of that value was quietly eroded by these unintended consequences.
And the policy lesson here is not to stop regulating pollution, but rather the absolute necessity of comprehensive multi-pollutant targets. If the central government had evaluated local officials on a combined index of both PM 2.5 and ozone, those officials would have been compelled to implement co-control strategies. That means aggressively clamping down on VOCs and NOx at the same time they reduced particulate dust. Because they didn't, a substantial portion of the policy's potential benefit simply evaporated.
This has broader implications beyond China, doesn't it? Many developing nations, particularly those with rapidly industrializing economies, face similar air quality challenges.
It absolutely does. This aerosol-inhibited regime isn't unique to China. Countries like India, for example, currently suffer from massive PM 2.5 burdens. If Indian regulators, in their efforts to clean up the air, also only target PM 2.5, South Asia could very well see a catastrophic surge in ground-level ozone over the next decade, repeating the exact same bureaucratic mistake.
And you mentioned earlier that controlling VOCs is often more difficult and expensive. Is that why officials neglected them?
That's a key factor. Tracking and regulating volatile organic compounds is vastly more complex and logistically challenging than, say, putting a filter on a single massive coal plant. VOCs come from millions of distributed sources: chemical plants, paint fumes, refineries, vehicles. Implementing multi-pollutant targets demands a much higher degree of state capacity and regulatory sophistication.
So the paper serves as a potent warning, not just for environmental policy, but for any domain where performance metrics are used.
Precisely. Whether targeting standardized test scores in education, wait times in hospitals, or PM 2.5 in the atmosphere, humans will always optimize for the metric you measure, and often neglect the ones you don't. This research makes a compelling case for the need to understand the full system before implementing policies based on single, narrow targets.
So, what are the key takeaways for listeners from this rigorous analysis?
First, that environmental successes, even those that seem clear-cut, can come with significant unseen costs if policy design is too narrow. Second, Goodhart's law is a powerful force, demonstrating how specific metrics can distort incentives and lead to unintended, detrimental outcomes.
And third, that understanding complex atmospheric chemistry is crucial for effective policymaking. Removing one pollutant without considering its role in the formation of others can simply shift the problem.
And finally, the ecological implications are profound. Policy decisions that seem purely economic or health-focused can have direct and measurable impacts on biodiversity, underscoring the interconnectedness of natural systems.
It leaves one wondering then how many other policy victories might have hidden costs lurking beneath the surface, waiting to be uncovered by equally rigorous research. That wraps up this episode of Paper Trail. Join us next time as we dig into more research worth talking about. If you liked what you heard, share it with a friend.
Keep reading the fine print.